Hello, I'm Dr. Ian McCullough, and in industry we hear a lot of these terms that are kind of thrown around. Data science, analytics, artificial intelligence, data-driven, quantitative methods, qualitative methods. And so I'm just going to throw a framework that I'm just going to propose to you that I'm basically adapting from Russ Bernard, who's actually an anthropologist. And I think it kind of puts some of these things in context, and maybe they're not agreed upon definitions, but at least it's a way of thinking through problems. So if you look at the data that you might have, right? There is qualitative data and there is quantitative, okay? So I'm just going to make a little chart here. And then there's methods. And methods can be qualitative or quantitative. Okay, well, let's think about that. Methods can be qualitative or quantitative. Data can be qualitative or quantitative. So what is qualitative data? Qualitative data might be things like passage of text, might be an image, might be a social group, might be a lot of different things, and so what is qualitative methods? Well, if I'm going to collect data in terms of I'm asking people how they feel about things, or I'm observing people responding in a focus group, or I'm doing some of those sorts of things, what I'm doing is I'm qualitatively analyzing qualitative data. And this is very common in military intelligence, where you read a bunch of different intel reports, and then you're synthesizing that, and you're kind of creating a consolidated report. It happens with a lot of lit review, where we read different papers and different points of view and perspectives and synthesize it. In a lot of government policy, people are doing that. So we understand that these are going to be things like, let's just say, all source, synthesize, right, aggregate, review. These are some of the things we're talking about. Well, let's look at quantitative data. Quantitative data is numbers. So if I, in a military setting, if I look at, hey, I want to know how many terrorist attacks have hit my forces over time, right? I might go and have like a little chart that's got like time here, and I might show, some sort of trends here, right? Like on a dashboard or something. And I might make a conclusion from that, hey, it's getting worse. Well, I didn't do a statistical regression. I didn't do a hypothesis test. I didn't do a p-value. I didn't really use a quantitative method. What I did is I took quantitative data and I qualitatively looked at it and made a judgment call, right? And so what this is where you're qualitatively like looking at a bar chart, right? You're looking at a dashboard, right? You're looking at some set of numbers, and then you're making kind of decisions, or you're getting insight. Well, what is quantitative analysis of quantitative data? Well, that's really the focus of this course, right? Is it's regression, stats, models, prediction, anomaly detection, right? Well, then what's quantitative analysis of qualitative data? Is that even possible? Well, I would argue that's things like computer vision, natural language processing. It could be machine learning. It could be artificial intelligence. It could be operations research. So you can do qualitative or quantitative methods on qualitative or quantitative data. And I think that is an important distinction to make. Why? My definition of data science is the application of quantitative methods. So data science can be the application of artificial intelligence and machine learning to qualitative data. It can be statistics. It can be mathematical modeling, optimization, prediction on quantitative data. But it is the application of quantitative methods that is hypothesis-driven. Hypothesis-driven. So that also means that you're not just going and saying, let me observe patterns in the data. Okay? What I would say quantitative data gives you is data-driven methods, right? So if we want to do data-driven insights, I'm looking for things that have numbers associated with them. That's data-driven. And I would place the area of analytics, what we typically see in practice, is in this, right, is the qualitative analysis of quantitative data. That might also be where we would do things like maybe certain types of exploratory data analysis, right? So if you are going to just get a bunch of numbers and you're going to start looking for patterns in them or that sort of things, what you're really doing is you're qualitatively looking for some sort of pattern or some sort of insight, and that's data-driven, it's important, it's analytics. That's different than data science, which is not just the application of quantitative methods, but it also has a hypothesis behind it. So what is a hypothesis? Well, this really lends us to what I call the ROAD methodology. So ROAD is an acronym, and so the R is standing for the requirement, or the research question. What are you trying to find? And then once you've defined a hypothesis or a question or an idea that you're going to try and prove, you can then operationalize with data. Now, we may not agree on the right data. If I want to understand what political sentiment is in Maryland, right? I might say, hey, well, I'm going to go look at Twitter. Well, you might say, yeah, but are the people in Baltimore on Twitter? Are the people that are voting on Twitter? Maybe we should use a face-to-face poll. Somebody else might say, well, people don't answer face-to-face polls, right? So this is where we're talking about operationalizing with data. Do we agree that the data sources that we have available or that we intend to go and collect are actually going to give us insight into the requirement or the research question we're looking for? Once you've then identified the data, right, then you can say, well, what's the proper method of analysis? Analysis method. Which of these different techniques should I apply on the data that answers the question? And at the end of the day, are you prepared to make a decision? And that decision can be as simple as confirm or deny the hypothesis, or it can be some action that you're going to take. And if you're not ready to make a decision, you've got to go back and say, did I not define the right requirement? Did I not operationalize? Did I not have a good analysis method? Or am I just not ready to make a decision? And if you're not, don't waste time with the expense and time of collecting data and trying to do analysis. And I believe that if you go with this ROAD methodology, right, you are on the road to success for data science because it requires you to have the hypothesis, which means that you're actually applying data science.